Hey guys, this is Mr. Grice for Algebra Unit 9 Final Exam Review. Alright, let's go ahead and get started. So number 1 says to circle the letter of the relation if it represents a function. You're like, Mr. Grice, I don't remember that at all. Well, remember that we talked about doing the vertical line test, okay? So the vertical line test, let me write it out, says that if you draw a vertical line and it passes through more than one point, it is not a function. Okay, so for A, I'm drawing a vertical line and it touched 1, 2 spots. So is it a function? No. But you're like, Mr. Grace, look at me, I drew it and it only went through once. Good, except as long as there's one spot that passes through twice, it's not a function. So you always want to try to find a place that won't work. Okay, for B, you could be like, hey, Mr. Grice, it only passes through once. All right, but what about this point right here, or this line? 1, 2, 3. Sorry, that is not a function. So right away, we know that A and B don't work. What about C? Is there any spots you can draw a line? Oh, not there. And I want you to try, not there either. Yeah, there's no spot. Okay, so C is a function. What about D? Yeah, D's a function too. Okay, there's no spot that you can draw that touches more than once. Okay, so our functions are C and D. All right, number 2 says to identify the domain and range of each relation. So domain, if we remember, is our x values, and the range is our y values. So let's take a look at it. Remember that we have to put the variable first that we're talking about, and is there a limit to how far left or right it goes? Remember, because that's our x. And you can be like, well, it looks like it stops right there. It does look like that, but our graph's going to get wider as those arrows go out, and it's just going to keep getting longer and longer and longer to both sides. Okay, so for the domain, we would say that it is all real numbers. What about the y? Remember, y is the up and down. I can see that it goes on down and down forever, but what about up? Well, yeah, that line right there, it can't go higher than that. So we would say that y has to be less than or equal to whatever number that is. So 1, 2, 3, 4. Y has to be less than or equal to 4. All right, B. What'd you get for x? Okay, well, going to the right, it goes on and on forever. And as it goes up, it also is going to come out. So for y, or for x, I'm sorry, our domain, it's all real numbers. What about y? I see that it goes up and up forever, but it never gets to what number? It looks like it gets really close, but it never quite touches -4. That's right. So we would say that when we're talking about the variable y, that y is greater than -4. It's not equal to -4, but it gets pretty close. All right, C. C is a little tricky. What do you get? First thing you should be looking at is our domain, and it goes on and on to the left and on to the right. So the domain is all real numbers. Now the y, it's like it's higher than that, but it's less than that. So we got to be really, really careful when we're writing this out. So off to the side on my paper, I wrote that y is greater than or equal to -3 and y is less than or equal to +3. So when we write this out, we would start with our lower number, point it to the left, and do that for both cases. That means that y is greater than or equal to -3 or less than or equal to 3. All right, D. Let's look at our domain first. Now it goes on and on to the right and on to the right, but does it ever get passed to the left of that line I just drew? No, it doesn't. So this time we actually have a restriction on our y, or our x, I'm sorry. That x has to be greater than or equal to +1. And for our y value, it goes on and on down and it goes on and on up, which means for the first time in all of these, that our y is all real numbers. Okay? So just make sure you are very, very careful when you are doing those. Okay? You got to pay very close attention and make sure to count the lines. All right. Next set. It says use the following functions to answer the questions below. I have 3 functions. We have the f of x, we have g of x, and we have h of x. So our first one says to find the values of f of x minus g of x. So what I would write down is I would write down what f of x is. That's going to be in the yellow. We have to subtract it, and we're going to subtract it to g of x, which is -7x plus 9. Now, this part should be a review from you guys. I can't remember what section of this was. We've gone through so many. But when we are subtracting, we have to distribute this negative inside, and it's going to change the symbols. Okay? That's a -7x. Now it's going to be a +7x. It's a +9. Now it's going to be a -9. Okay? And now we look to combine like terms. My highest exponent is an x squared. There's nothing to combine it with, so we get x squared. -8x plus 7x. That's right, gives us -x. And then the last thing we've got -6 minus 9. What's -6 minus 9? That's right, it's -15. So our final answer would be x squared minus x minus 15. All right, for 4. 4, we are multiplying g of x times h of x. So our g of x was the -7x plus 9, and then the 3x squared plus 5x minus 1, okay? And we are multiplying. Now, you can do this 2 different ways. Some of you guys are huge fans of distributing, where you would go through and multiply everything on the top, and then multiply again everything on the bottom, okay? To make sure that it distributes to everything. I'm not a big fan of that because I get easily confused with stuff. So I like to stay very organized. And I'm going to do the box method. You guys can do whichever method you want. Okay? So I have a trinomial times a binomial. I'm going to put my binomial on the top, or the trinomial on the top, and the binomial on the side. And now we just multiply. Negative 7x times 3x squared is negative 21x, and got to remember that we add the exponents. Negative 7x to the first times a positive 5x to the first gives me negative 35x squared. Negative 7x times negative 1 gives us a positive 7x. Positive 9 times 3 gives us a positive 27x squared. Positive 9 times positive 5 gives us positive 45x. And then for the last box, we have 9 times negative 1, which is negative 9. Now, the next step would be to combine your like terms, and then you can write your final answer. So why don't you guys go ahead and try to do that? So you should have gotten negative 21x cubed minus 8x squared plus 52x minus 9. I know that line was kind of hard to write all that stuff. All right, so if you're curious to how I got certain things, I highlighted the gray and the yellow, and that's what I combined, the two grays and the two yellows, to get those numbers. All right, find the value of f of negative 5. So all that means is that we're going to take the function f of x, and we're going to plug in to x squared minus 8 times x minus 6. And why don't you guys pause the video? Yes, pause. There's a button. It's the pause button. And try it on your own so you don't just wait around and see the answer. Good luck. Okay, and you should have gotten f of negative 5 equals 59, and I showed a little bit of work below. Okay, let's flip it over. It says to graph the function and evaluate the function for the given value. So we have f of x equals negative square root of x plus 2 plus 3. So when we are drawing this, or graphing this, first thing we got to know is there a reflection? Okay, and the negative outside tells me that there's going to be a reflection, and my graph's going to look like that, going down. Okay, remember, square root's got a special pattern. Now the next thing we need is the initial point. The initial point is like the vertex. So I take the opposite, and this stays the same. So our initial point is negative 2 comma 3. And then we graph. So I'm going to start at negative 2, positive 3. There's a reflection, so I'm going down. Down 1, right 1, down 1, right 3. And then from there, we just graph. So f of negative 2. When we plug in 2, what do we get? Okay, I know some people struggle a lot with this, but all you're telling me is that point is 2 comma 1. Our answer is 1, because it's just, where is that at? Well, it's at 1. All right, number 7. Graph the function and evaluate the function for the given value. If you want to try this one on your own, go for it. Just pause the video. Okay, so first off, what type of graph is this? Those lines mean that it's going to be an absolute value. And since there's no reflection, my graph's going to look like that. It's a V. We need the vertex. We take the opposite of the inside, and the outside stays the same. Okay? So at 1, -4, and then for absolute value, we just go up 1, right 1, up 1, right 1, left 1, up 1, left 1, up 1, and we just continue that pattern. Okay? And then I'm going to draw the lines. So find f of -3. Well, at -3, 1, 2, 3, what's that point? Well, it's the point -3, 0. So our answer for this is 0. All right. Graph the following piecewise function. Now, the first one that we have is quadratic, okay? It's telling you right there with the little square. There is a reflection, and our vertex is 2, -2, okay? And we have to pay attention to this limit. I'm just going to draw this in here right now so I know it. And for the quadratic, I only want things to the left because it says less than. So at 2, -2, I draw an open point, and now I do the rest of the graph. Okay, so I'd go left 1, down 1, left 1, down 3, 1, 2, 3. And so that's the only thing that we care about for the first part of the graph. Now, for the second part of the graph, we'll do in red. It's linear. My slope is 3/2. We start at 0, -5, but same thing. Our limit is that we want things that are greater than 2, okay? So when I start this graph, yes, I have to start the graph at -5, which is right here. I'm going to delete that point in a second, but I have to follow it. I have to go up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2. Okay, I'm going to delete that first point, and now I'm just going to continue my line, or draw my line. So there we go. Now, thankfully, it's not asking us to talk about the domain or the range in this. So we're done. Now, if you have any questions on this, please ask Ms. Kranzer or myself. We would love to help you out. Otherwise, that's it for Algebra Semester 2, Unit 9, Final Exam Review. Thanks for watching.